We have a Gree Mini Split air conditioner PCB. The person who brought it says it's a completely new PCB. When they installed this circuit, it started showing an E6 error. They claim they installed everything perfectly. The line, neutral, and the signal wire were all connected correctly. But as soon as they switched it on, it began displaying the E6 error. Now we need to see what the issue is. First, let's check the fuse. We'll put the multimeter in continuity mode to check it, and it's showing perfect continuity. Look, this is the fuse that is installed, which is a 102 fuse. I've mentioned this in another video as well, so let's check it to see if it's good, because if this fuse is fine, then there's an issue in the unit. And it's fine. And now we will check the rectifier. When checking the diodes in the rectifier, we should have positive on positive and negative on negative, and we shouldn't get any values. Now change the polarity. Now we should get a voltage drop, and everything is perfect. Next, let's also check the IGBT to see if there's any short circuit, because this is a completely new PCB, and the IGBT is also perfectly fine. Now let's check the diode again, and we'll check it in reverse polarity as well, and that's also fine. Now let's check the IPM. There should be no value showing between negative and positive, and as we can see, there's no value here. It's completely fine. Now, what we need to do is give power to the PCB, because it'll be a bit difficult to find the fault without power, since the high side and fuses are perfectly fine. Next, we'll check the system's low voltages. Let's see where the low voltages come from. We'll check the entire SMPS here, including all components like the diodes, resistors, switching IC, chopper, and all voltages to see if they are being generated correctly. This will help us identify where the fault might be. Now, the PCB is fixed in the holder. Now we'll give it power, and then check all the points for the voltages. First, let's check the capacitors to see how many volts we're getting. We're getting 308 volts here. And now for the ICA6061H. We find a positive point at its output because we can get the positive drain from the switching IC. So we'll connect one probe to the negative point, and you can see here are 2 points on the output side, and this point is connected. We're getting 308 volts here, which means the output voltage is perfectly fine. This means we now need to check the rest of the low voltages. There are 3 capacitors here, and we should get 5 volts, 12 volts, and 15 volts on them. Let's check what voltage we're getting on each. We'll keep the negative probe here and take the positive reading from this capacitor, where we're getting 5 volts, so this capacitor has the correct voltage. Now let's check the next capacitor. As you can see, there's no voltage here. Checking the third capacitor also shows no voltage. This means our 12 volts and 15 volts are missing, but we're getting 5 volts, which should have powered the microcontroller. Since there's no voltage on the other points, it could be that the chopper is faulty, or it might be a diode or switching IC issue. But how do we determine which it is? Let's move on to the next step, where we'll check everything thoroughly. Now we're using advanced techniques. What does that mean? We've employed an oscilloscope to determine where the fault lies and why the voltages are low. Specifically, we're getting 5 volts but not 12 or 15 volts. First, we take the grounding from here because the positive point should be at the switching IC, so we'll use its negative point. Now we'll power it up, and the oscilloscope is ready. We will check the voltages again and see that we're getting 4.80 volts, and the fluctuations are quite minimal. Next, we'll check the capacitor. Here we notice the fluctuations, and there's no voltage at all. Now let's check the next capacitor, and again we see a lot of fluctuation, indicating an issue. So, we need to check the switching IC. We connect to the output of the switching IC since it was producing output earlier. We take the output and press auto on the oscilloscope. And as you can see, there's a significant fluctuation here as well. This indicates that the switching IC is failing, confirming that there's a problem with the switching IC. Now we'll change the switching IC. Let's also check this capacitor, and we find it's showing 11 volts. Now we've checked everything. We've also checked the switching IC, and it's providing its output. However, there's one thing we haven't checked yet, the resistors and diodes. These diodes are safety diodes, so we need to check them because the system cannot function without them. Look, there's one diode here, and this diode is for the 11 volts we measured earlier, so it should be functioning properly. As you can see, it's perfectly fine, and we'll also check it in reverse polarity. It is fine in reverse polarity as well. Now, let's check the next diode, which is diode number 123. First, we'll check it in reverse polarity, and then check its cathode and anode to see if it's fine. Next, we have diode 125, so let's check that. It's also perfectly fine. And now let's check it in reverse polarity as well, and that's fine too. Now there's another diode here, D124. Let's check that one. Oh, it turns out this diode is faulty, which means that all the fluctuations we were observing were due to this diode. So we'll replace this diode, and then we can continue working on the switching IC. Now what I've done here is remove all the capacitors from the SMPS, and I've also taken out this diode. However, when I remove the diode, I still see a short circuit, and the diode itself is perfectly fine. So where could the fault be? Besides this, there's another diode here that I'll show you. As you can see, I've also removed that one. Let me check it. Checking it in diode mode, it also shows 0, which means we need to find out where the problem lies. The issue is with this IPM. It's the fan IPM that is faulty and causing the short circuit. We will replace this IPM and then check if the PCB turns on or not, and we'll put the other parts back in to see if everything is working properly. Now, as you can see, I've removed the IPM from here. After taking the IPM out, I've reconnected the diode, and now let's see what value it shows. Previously it was showing 0, but now it's giving the correct value. We'll also check this area, and you can see that the diode is showing a value which is perfectly fine. There's no issue here because the short circuit has been resolved. Once the IPM is changed, this PCB will work perfectly. Now this PCB is completely fine, and I have changed the IPM. You can see that we're going to power it up now since I've done all the settings. So let's power it on, and look, it has turned on, the lights are on, and it's working perfectly. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.